As a programmer, we should be very confident on every word and every line that we put in our code. Unfortunately, when I ask the questions related to code snippet to the same person who has brought that code to me, people are not able to answer. One such example I recently found was random.seed. What this does, why you use this, right? Let's try to understand this concept, because this is one thing that is used at many places. If you are a data science beginner, then you may be finding this video very useful. Let's start, guys. So guys, in this video, we are going to understand 5 things mainly. One is how machine learning uses randomness. We will see some examples of that. Then we are going to see randomness and reproducibility in Python. I'm going to show you some examples of how randomness and reproducibility works in Python. Okay. Then I'm going to tell you what works behind the scene when you do such kind of seeding, or when you want to reproduce one output, then what happens behind the scene. Not in too much detail, because that is not needed for us, but still you should know, because sometimes in interview they can ask you. Okay. Then we will see how we can do reproducibility in advanced models such as TensorFlow, PyTorch, etc. And then I'm going to leave you with some questions, okay, to test your machine learning knowledge, to test your concepts. Okay. So let's see, guys, how machine learning uses randomness. I'm sure you have come across many examples, many things where machine learning uses randomness, or something to do with the randomness. Some of the examples are here. I have just written here. For example, when I do a data split between train and test, right? So most of you know that it does the data split by using randomly 75% it will take in train, 25% in test validation, whatever you call it. That split is random. Okay. So that is one place where randomness is used. Now, what I'm going to show you in Python example is when you say random.seed, right? Or seed, random.seed, then what happens? This is what I'm going to show you now. But first, data split, we use randomness, the concept of randomness. Feature engineering, multiple places we use concept of randomness. For example, creating synthetic data for undersampled data, we use randomness. Maybe undersampling and oversampling also, we use some kind of randomness. Many algorithms, many feature engineering processes use some kind of concept of random number generation, or random sample generation, or random data point generation, you can say. So heavily we use in feature engineering the concept of randomness. If you talk of cross validation, right? So what happens in cross validation is, let's say entire data is broken into 4 5 pieces, and then I will train my model on these four, and I will test my model on this, and then I will shuffle it. So this is again random. For example, this piece is randomly broken, and then this is done, right? So again, the concept of randomness here. Weight initialization in neural network, if you see um, different types of weight initialization, right? One is known as random. Then there are some other initialization techniques where random in some or other way comes into picture. The use of random numbers, or it will tell you, take from the uniform distribution. From the uniform distribution, take these many numbers, right? So that also becomes one kind of putting randomness in the initialization of the weight, right? So that is weight initialization. In neural network, you use random concept of randomness. Then algorithms such as random forest, the name itself says random. K-means clustering, to initialize your clusters. Basic k-means, I mean to say plain k-means in its vanilla form. And many other places also you might be seeing randomness. I want you to comment here what all feature engineering places, or what all machine learning modeling places you see the concept of randomness. Okay. Why I am discussing all these things here is because you might be seeing one, all the newcomers in data science, you might be seeing one random.seed. People will say seed is equal to 10, okay, or something like this. Random.seed is equal to 20, some number they will provide. Not many people discuss on what's happening there. Let's see that in Python. Okay. So let me go to Python, and let me try to import a package called random here. If you can see, I'm importing a package random. The use of this package is it will give me random integers between 1 to 100. I'm asking this package in the first block of code. I'm asking this package to give me one random number. Okay. So let me run this. So you can see it is giving me one random number 5. Let me run this again. So you will see that it is giving me a different random number 55. Let me run it again. So you will see that it is giving me a different random number 62. Let me run it again. You will see it's giving me a different random number 74. Now imagine a situation where I want to get the same random number whenever I want to run it. That concept is called reproducibility. The concept of reproducibility is whatever I'm doing when next time I run, for example, if 74 is the output here, right? The next time when I run, I should get 74 only. Okay. And how that is possible is I will simply go and set a seed here. For example, I will simply go and set a seed. For example, I will give 11 here. Now let's run this. You will see 58. Next time, let's run this. You will see the same number next time also. Okay. So now how many ever times you run, right, you are going to get the same number in the output. Though I'm calling a random integer function, but since seed is fixed, so you are going to get the same number. Okay. Same thing I'm doing here. I'm running that function 5 times with a random seed of 10. And you will see that every time this produces the same result 74, 74, 74, 74, 74. Okay. So what's happening here? I'm reproducing the same number by setting a seed. Let's see the another example of train test split here. As you can see here, I'm creating X and Y, just some sample X and Y. Okay, so my X and Y looks like this. Okay, my X and Y look like this. My X is basically this part from here to here, and my Y is basically range 0 to 5. Okay, that is my X and Y. Now what I want to do, I want to break, split in train and test, and I want to use a random number to see what's happening here. So let's go ahead and try to break this. You can test it with a larger data set, guys. So I'm just running this, if you can see. Okay. And if you note here, I'm running without random seed. Okay. I'm running this without random state. And here you can see 2, 3, 6, 7, 4, 5, then 1, 3, 2, then 0, 1, 0, 4. So let me put it somewhere so that we can compare with the next run. So let's put it here. Now again, if I run this, right, you will see different sets is going in train and different set is going in test. See here, X train had changed, X test had changed. I'm comparing with this value. Okay. And then Y train had changed. Sorry, X test has changed and Y test has changed. If I run it one more time, it will change again. See here, the same thing happens with a larger data set also. So if you break it, it will randomly start taking the values. I'm doing the same experiment here with a random state is equal to 42. I'm just passing a number here and then I'm doing the same exercise. So let's run this and let's copy the result and let's put it here. And in the next time when I run, I will compare. Okay. So see here the same result. See here the same result. See here the same result. So with these two examples, what I'm trying to show you is what is the use of this random state or random seed. When you give a seed, then what happens? Okay. So it is the concept of reproducibility. Please understand these concepts carefully, guys, because in machine learning world, you want sometimes when you are working with single model, you may see these things as simple things, but when you are running on a large experimentation mode, right, then concept of randomness and reproduction is becomes very, very important. So here, this is what is happening. Now let me tell you what happens behind the scenes when you say random.seed is equal to 11 or some number. So in the world of computer science, what happens is there is a concept of deterministic approach and non-deterministic approach, which means by doing something, can I find out what will be my numbers? So just try to think it like this. Is there a function which maps, which knows if I know that function? Imagine there is a function. If there is a function, can I deduce that it will give me 58 only? Can I deduce that? Okay. If I can deduce that, then that's the deterministic approach. And if there is no function or no connection through which I can know what my number will be, then that's a non-deterministic, or we don't know what is happening behind the scenes. What Python uses behind the scene is something known as, you can see the Wikipedia page here, something known as Mersenne twister, if I'm pronouncing it right. So you can see here, Machine Twisted is a general purpose pseudo number generator developed in 1997. No need to know much detail of this, but sometimes what happens is in some MCQs and in some interviews, people may throw these terms to you. Okay. Just remember, machine twisted is what Python's random uses. Just to be double sure, if you come to a random page, right, of Python and you search this term, right, this is how you should relate different things, guys. If you said come here, see Python uses the machine twister as the code generator. So every time I'm calling here, random.randint or passing a seed, what is working behind the scene is this approach. Okay, just no need to go in much detail. We have anyway million things to learn in machine learning and deep learning, but just know that what Python uses behind the scene. Okay. Now, what I want you also to know is when you are working with complex models such as TensorFlow and Chaos and Torch, PyTorch, right? Then try to find out what is the equivalent random generator for that. For example, here you can see tf.random set seed. Now this set seed is a useful function for you. You can use for things inside TensorFlow. Similarly, if you go to PyTorch, here you can provide manual seed and you can provide a number. So just see how this works and how you can provide a number and how you can regenerate the result. Okay. Um, Now my question to you is, as I told you in the beginning, right? I also want to test what is your understanding of machine learning and deep learning and model in production. My question to you is, in production, will you use, I'm writing here, you can comment me, in prod environment or when you deploy your model, right? Will you use seed or randomness? Will you use seed function? I'm just writing here. Seed function means you can think of setting a seed in any of the framework you are using, right? Will you use a seed function when you are deploying a model? And if yes, then for what purpose? Okay. Think on this, guys. This is not a simple, straightforward answer I'm expecting from you. Think on this and then comment me what is your analysis of. If you want to use seed, then where? If not, then why not, right? So just know these things, whatever I explained you now, and keep an eye on wherever you are using seed, randomness, right? So just see that it is falling in sync with what you want to do with your analysis. Okay. I'll see you all in the next video, guys. Wherever you are, stay safe and take care. Please give me a thumbs up if you like this video and don't forget to subscribe to Unfold Data Science. Thank you so much, guys.